Honors Algebra 2, Chapter 4 and 5. This is the last part of the factoring. This is actually Section 5.4, Chapter 5, Section 4, about factoring polynomials. And there's some methods here that we've talked about, like grouping before. We're going to look at that again. Talk about perfect squares. We're going to look at that again, but we're going to look at it as cubes. And then we're going to look at degree 4 trinomials. Some different patterns here. For grouping, we want to get to this form where we have this common group in the terms. So we have these two big terms. Each term has a common group in there that we can factor out. So for this one, we pull out the x plus y. This x plus y that's in both of the terms. We factor that out. You're left with a 5 plus w, the parts of quantities. Difference of perfect squares. We should recognize this. We have a perfect square and another perfect square. We can square root those. And we'd find a, and then 8 and 8, and then the signs are just opposite. Our OI value here, outside, inside, would be 0. That's why there's no middle term, and we have two terms there. Now, some of the difference of cubes, we're going to talk about that more in depth here, but when you have a cube, so a variable cubed or a quantity cubed, a perfect cubed, so if you cube root this, so like the cube root at the square root, cube root of a to the third is a, and the cube root of 8 is 2, because 2 times 2 times 2 is 8. And so that's what we're talking about here, and we're going to look at how to break that up more in the future slide. And the last one is degree 4 trinomial, and it's a trinomial but it has power 4. But look at the pattern: power 4, degree 2 for that term, then degree 0 for this term. And so that pattern 4, 2, 0 is what you're looking at, and how you factor it is pretty much the same we've been doing. Your factors here just have a squared and a squared, and then you can look at the rest of it how we did previously in factoring. Actually 4, 3 for this one, because the coefficient, the leading coefficient is 1, so we're looking at what two numbers multiply to be 5 but add to be 4. So we're looking at what values that multiply to be 5, add to be 4, but for this one, this is not factorable. There's no value that multiplies to be 5 but adds to 4. So factor by grouping. To review this, we had a whole day on this yesterday. So we want to group the terms here. So we group the first two and group the second two terms. Sometimes you might need to rearrange the groups to make it work. And then after you group the terms, we're going to factor each term. So in the first one, we're going to pull out the b. You're left with a minus 2. In the second one, you're going to pull out a c, and you're left with a minus 2. And we need those parentheses to be the same. And then we factor that same quantity out of both terms here. So we factor out the a minus 2, and we're left with the b plus c. Just another example for grouping. Another example here. I'm going to have you try this one. This is going to be one of your homework problems. You're going to have two homework problems or video problems tonight. This is video problem number 1. So factor using grouping. Factoring, this is like a difference of perfect squares, and so when you're looking at the problem, you're looking for, can you square root those two terms? And so when we look at square root of 16x to the 4th, square root the number is 4, square root x to the 4th, it's always half your degree, so it'll be x squared. And the square root of 81 is 9. And so that should help us factor it. So we have 4x squared minus 9, and we have 4x squared plus 9. So we check OI, your outside is going to be 36x squared, your inside is negative 36x squared, so we have the 0x squared in the middle. But we're not done here, and this is what we have to realize, is that you always have to keep checking. You factor once, can you factor any more? So in this quantity here, there's nothing that's factorable. But if we look at the first grouping here, this is another difference of perfect squares. We can actually break that up into two quantities by square rooting each term again. So it's going to be 2x minus 3 and 2x plus 3. And then we can write the other quantity group down there. So we need to factor that first quantity again a second time to fully factor the polynomial. Factoring difference or sums of cubes. So when you look at this, similar to the previous one, we were squares. This one's cubes. So if you can cube root these two, the first thing you want to do is you want to cube root 64, so that's 4. Cube root x cubed, which is x, minus cube root 27, that's 3. And so we're going to have a trinomial left out over here. So cube rooting, 3 times 3 times 3 is 27. I know 4 times 4 times 4 is 64. So you should know some of these cube roots for 1 to 5. After we have that pulled out, if we were to look at our logic to distribute, if we distribute the 4x times this first term, this x squared, that gives us the 64x cubed. So my logic here is, what do I need to multiply 4x by to get to 64x cubed? So 4x times what equals 64x cubed. And what I'm going to use there, what I'm going to multiply by, this stays the same, is what it's going to be in this blank. So 4 times 16 is 64, and x times x squared is x cubed. So that's the first thing I'm going to do, is find that term. The next thing I want to look at is, so I'm going to look at the negative 3 multiplied to this last term here. This constant should equal this negative 27. So negative 3 times a positive 9 is going to give me the negative 27. So let's rewrite that with our positive 9 in it. And so we're finding the pieces to the puzzle here. We still have this open piece, but we have the plus 9 now. Now, similar to OI from before, we can look at, if we're distributing this 4x through the trinomial, 4x times this term, which is going to have an x in it. It's a trinomial, x squared x, then no x. So 4x times this x, not sure what that value is, needs to be the same as the x squares from the negative 3 times 16x squared. I know that coefficient. Negative 3 times 16x squared is negative 48. So 4x has got to be positive 48, and that's going to come from 4 times 12. So now I have all of the pieces of the puzzle. Whenever I'm done factoring, I want to kind of check to make sure I'm right. And so we always check OI. For this one, we can go back and check the other values, the x's. So 4x times 9 and then negative 3 times 12 is another way of checking the problem. Similar to what we did here in purple up here. But 4x times 9 is 36x. Negative 3 times 12 is negative 36x. So those also drop out. Because in this perfect cube, there's no x squares, there's no x's. So the coefficients have to be 0. These coefficients have to be 0. So that's why I'm always using that logic to find the piece of the puzzle to make sure it works out. And so that's factoring cubes. I use that logic. There's a formula to follow to get that. I typically don't use it. I typically use that logic to understand how to factor, which actually helps me factoring all the other methods once I master that logic. The last method of factoring we're talking about is factoring trinomials. When we have the degree 4, then degree 2, then degree 0. So when you factor that, it's really the same exact thing as factoring this problem. If I was to factor this problem, it's just a basic trinomial, degree leading coefficient 1. So I'm looking for two numbers that multiply to be negative 21 and add to be 4. So positive 7, negative 3. Pretty quick and easy. So that's what we're doing here. We want to factor that. And I think I'm just showing you we factor as if it was that quantity, which I just did for you. But we're going to do the same thing, but instead of using x squared, we're going to use x squared rather than x's when we factor it. So when we break it up, we're just going to put x squared and x squared. And then the numbers are the same, plus 7 minus 3. Because now if you look at when you're foiling, x squared times x squared is that x to the 4th. Because you add the exponents. The 7 and the negative 3 is negative 21. And then you can check your OI value here. Our OI, x squared times negative 3 is negative 3x squared. And our I is 7x squared. So OI is 7 minus 3 or 4x squared. So factoring these is not very different than when we're factoring our basic trinomial. Now when we are done, we got to double check. Can you factor this quantity? No. Can you factor this quantity? No. Sometimes when you do this, you might get a difference of perfect squares within here. So if this was x squared minus 4, I need to keep factoring. But 3 is prime. It's not a perfect square, so we're done with that. Here is the last problem, the second problem. There's 2 video problems. This is number 2 for you to do over the night, factoring the perfect cube. So make sure you go back and look at the steps I went through to factor that one. It's a more difficult one, and use that to help you factor this. So have a good night.